Welcome back! Today we're diving into LIN communication, and I'm going to show you how to connect, analyze, and control it using the INPRONIC LIN Bus daughter board. Let's start. Step 1. Locate the LIN communication wire in the vehicle. In this case, we're working on a Jeep Patriot 2017. Always verify the wiring diagram to correctly identify the LIN signal line before making any connection. Step 2. Connect 12-volt, ground, and the LIN signal wire to the LIN Bus daughter board. This board allows us to safely interface and interact with the LIN network. Next, connect CAN high and CAN low from the daughter board to the INPRONIC trainer. This establishes communication between the LIN system and the trainer platform. Once the ignition is on, the daughter board initiates. The red LED indicates that the board is active. To activate transmission mode, we now move to the software. Since our USB cable is connected to the upper board, we select the corresponding COM port, in this case, COM12. After selecting the correct port, we click Open. Next, under Protocol, we select OBD2. Below that, we configure the CAN speed to 500 kilobits per second. Then, we press Start. On the right side, under Transmit Data, we now send the frame that activates LIN communication. In the header, ID 0x, we enter 1E2. Under Data, we always send 0x01 in byte 1 to enable LIN activation. For this vehicle, a Jeep, the LIN speed is 9600 baud. This value must be entered in Little Endian format in bytes 2 and 3. So 9600 converts to hexadecimal 2580. And in Little Endian, we enter 8025. Depending on the make, model, year, and trim, the LIN speed will vary. That means different hexadecimal values and different Little Endian combinations, but always placed in bytes 2 and 3. After entering the required values, we press CAN TX. When the red LED begins blinking rapidly, this confirms that the system is now in transmission mode. To capture LIN Bus communication, we now switch the toggle upward. When the green LED turns on, this indicates that the daughter board is now operating in sniffer mode. In this mode, the daughter board listens and captures all LIN communication in real time. Now we'll demonstrate real control commands, activating and deactivating the vehicle actuators. While on sniffer mode, we will click Sniffer in the software. Here, we can see all LIN communication traffic in real time, allowing us to capture and analyze the data being transmitted. While in sniffer mode, we manually turn the lights on and off inside the vehicle. As the lights activate and deactivate, we observe the corresponding LIN frame, in this case, located in row 4. By comparing the changes in the data, we can identify exactly which bytes are responsible for controlling the lights. Once we identify the correct data, we must return to transmission mode before sending any commands. We toggle the switch to position 1, and the red LED continues blinking rapidly, confirming that the board remains active and ready to transmit. Before sending new data, we clear both the RX and TX buffers by clicking Clear RX and Clear TX. We now change the ID 0x to E2. Under Data, we enter 00, 40, 00, 00, BF, and the remaining bytes set to 00. These are the exact data bytes captured in sniffer mode to activate the lights. Before pressing CAN TX, we disconnect the LIN cable from the vehicle, in this case behind the steering wheel. This step is critical to prevent interference from the original module. Now we press CAN TX. The lights activate immediately. The lights will remain on until we send the command to deactivate them. To turn them off, we modify the corresponding data bytes to 00 and FF. Once again, we press CAN TX, and the lights turn off. We repeat the same process for the windshield washer system. We switch to sniffer mode and manually activate and deactivate the washer inside the vehicle. As the state changes, we monitor the corresponding LIN frame, again located in row 4. Once the correct values are identified, we return to transmission mode. Without changing the ID, we simply update the necessary data bytes. In this case, byte 3 is set to 10, byte 5 to EF, and the remaining bytes remain 00. We again disconnect the LIN cable, and now we press CAN TX. The washer activates immediately. To deactivate it, we transmit the corresponding OFF frame, modifying the required bytes to 00 and FF. We press CAN TX once again, and the washer system turns off. To deactivate the daughter board, we return to the activation frame. In ID0X, we enter 1E2. Then, we set the first byte to 0x00. After pressing CAN TX, the red LED begins blinking slowly. This indicates that the LIN Bus daughter board is now off. This is how you can learn and master LIN communication with INPRONIC, USA.